Okay, in this video, I'm doing a revision for the N-level metals chapter. Questions in this video are selected based on my student. The questions here are something that my student happen to have problems with. So before I go through the questions, so I will do some quick recap of something that the question requires. So in this slide, we talk about some physical properties of metal. So we do know that, or we are told that metals have high density. So why metals have high density is because metals have atoms in the metal have this structure. So the atoms are packed closely together with little empty spaces. So that's why metals have high density. Okay, then we know that density is mass over volume. So the density will be high because mass is usually high within a given volume. And why the mass is high is because they are packed closely together. Okay, that's one characteristic. Then the second one is second physical property is that metals are malleable and ductile. So why they are malleable and ductile is because that metal atoms have the same size and then they are packed in regular layers. So if you were to exert a force, a push, then the layers would slide over each other. So if they were to be able to slide over each other, then they can change, the metals can change shape very easily, or they can be turned into longer, they can be pulled into wires very easily. So the layers slide over each other easily and they will stay in their new position. So that's why they are malleable and ductile. So this question is an MCQ question. We have 4 elements, A, B, C, and D. So the question says, right, suggest which element is used to make aircraft bodies. So first we have to think about, an aircraft, so airplane, the helicopter, chopper, whatever you call it, whatever you have, what would you expect the property to be? If it's, so down here we have 2 characteristics that we have to examine. One is density and the second is malleable or it's brittle. So if it's high density, say the first 2 options, high density would mean that the metal is heavy. Low density probably would mean that the metal is lighter. So if I have a metal and I want to use it for aircraft, that means we need it to fly. We need the aircraft to fly. So would you want a metal which is heavy, or would you want a metal that is light? So if it's too heavy, I don't think the aircraft can fly. So the option A and option B is out. So then now we go to C and D. We have light density, but one malleable and one brittle. Brittle means it breaks very easily. Then malleable, that means it can be beaten into different shapes easily. So in that case, right, we want to be able to shape the aircraft body. So that means the metal cannot break easily. So that means we cannot have a piece of metal or piece of element, an element to be brittle. So this is out. Therefore the answer is D. So before we go on to the next question, we will need to know what is an alloy. So an alloy is a mixture of metal and other elements. So over here we have a diagram to illustrate how the atoms of different elements are being arranged in an alloy. So you have element X and element Y. Then the atoms are of a different shape. So we usually add the added element, we usually have metals. Sometimes we can add non-metals such as carbon. For example, you can have steel, which is just iron plus carbon. That is an example of alloy. So question 2. We have two statements about alloys. So one is aluminium contains a small amount of copper is considered an alloy. Number 2, alloy can be made by mixing molten metals together and allowing them to cool. So which of this statement is true? So we can go back to our say alloys down here. So in order to get the alloy, the structure of the alloy, in order to have two metals to mix, or a metal and something else to mix, you have to get them into the molten form so that the atoms can move and then they can rearrange themselves. So number 2 is correct. Say number 1, aluminium that contains a small amount of copper is an alloy. So it's shown down here. The added elements are usually metal, so the alloying element is usually metal. So over here we can agree that aluminium with small amount of copper is an alloy. So this is also correct. So then we come to these 4 options. We have to pick the ones that both statements are correct. So C and D is wrong, so they're out. So then we have to decide whether A is correct or B is correct. Both statements are correct and statement 2 explains statement 1. Then, so now we have to take a look at these 2 statements and see whether they are related or not. So these 2 statements, 1 and 2, they are not related. I mean, you don't use one statement to explain the other, do we? I don't think we do. So they are not related at all. So statement 2 does not explain statement 1. So then our answer is B, because the 2 statements don't explain each other. So to do the next question, we need to be reminded, we need the recap on the reactions of metal with cold water. Metals that are reactive will react with cold water to produce an alkaline solution. So in this case, metal reacting with cold water will produce metal hydroxide and hydrogen gas. So back to this, you see that potassium reacts violently to form potassium hydroxide and hydrogen gas, and you see that the reaction is very vigorous and hydrogen gas may catch fire and burn with a purple color flame. So sodium reacts in the same way, so it also reacts violently, now producing sodium hydroxide and hydrogen gas, and the hydrogen gas may catch fire again, then this time around the flame is yellow. So we go down the reactivity series, then we see metals like calcium, magnesium, zinc, iron, lead, copper, silver, which is whatever is in our syllabus. So calcium, you see that it now is reacting readily. The degree of reactivity has, how vigorous the reaction has gone to, right, it actually has dropped. So we look at the next few metals like calcium, magnesium, zinc, iron, lead, copper and silver. So you see, when it comes to calcium, the reaction, how vigorous the reaction is, it mentions it reacts readily. So it is not as violent as potassium and sodium. Then it also forms calcium hydroxide and hydrogen gas. The metal and the gas doesn't catch fire right now. Then if you look at the next one, you see magnesium. The reaction is very slowly, and then you get magnesium oxide, magnesium hydroxide and hydrogen gas. So then the rest of the metals like zinc, iron, lead, copper and silver does not react at all. So we can see that the reactivity drops. So in question 3, we have a question regarding the reactivity of metals. So you say we have a shiny gray solid and then it reacts vigorously with cold water. Then it forms a solution that turns red litmus blue. So red litmus blue will mean there is a alkaline solution. So you have an alkaline solution that is formed. Then this shiny gray probably indicates it's, by appearance, it's probably a metal. Then a metal react vigorously with cold water. So from here you will see that only potassium and sodium would react vigorously with cold water. So then we come back, we want to find the identity of X. So then we know just now it's only sodium and potassium. So we will go back, so we'll go to the options, so the list of options here, and then just look for sodium or potassium. So answer is C. So our next question requires our knowledge on metals reacting with hydrochloric acid. So back to that list of metals again. So you'll notice that in this list there is no potassium, no sodium, no calcium. If potassium, sodium and calcium reacts vigorously with cold water, it would be the reaction between that three metals with hydrochloric acid would be extremely vigorous. So those three are not included because probably you have an explosive reaction with acid for those things, those three metals. So the table starts at magnesium. You will see that magnesium reacts rapidly with acid to produce hydrogen gas. Then zinc reacts moderately fast, and then iron reacts slowly, and lead gives you a very slow reaction, and copper and silver has no reaction with acid. So that's what the reaction of metals with hydrochloric acid, the knowledge we need to know is about this. Now question 4, okay, we are given pieces of metal, so copper, iron and magnesium. Then they are added to dilute hydrochloric acid. Then the reaction will show these three observations. These three test tubes. So test tube 1 has moderate amount of effervescence bubble. Then test tube 2 will have 0 bubbles, and then the last one, right, it has the most amount of effervescence, or we call it bubbles down here. So then based on that, right, based on the amount of hydrogen gas or the amount of bubbles that is being produced, you can determine which metal has the highest reactivity and which metal has the least reactivity. So the metal that has not produced any effervescence or bubbles, this is the least reactive, and the one that has produced the most effervescence or most bubbles is the most reactive. So we have this conclusion down here based on the observation. So we take this observation and then we go to the table. So we are supposed to arrange or figure out which option is correct based on our knowledge of the reactivity of the metals, and then those observations must coincide with our knowledge. So so we have copper, iron and magnesium. Based on the reactivity series, we know that copper is the least reactive. So if you don't know, please go to your reactivity series and refer to that info. So this is the least reactive, and then magnesium here out of these three is the most reactive. Then come to here, test tube 2 should show us copper. So we will strike out those that we don't have copper as test tube 2. So now we are left with A and C. So in 3, test tube 3 is the most reactive, so test tube 3 must be magnesium. Then we strike out the one that is not magnesium, we have answer is A. So next part is about recycling. So this infographic will show you how much metal, how many years we have for certain metals. Like, so the longer the bar, that means the more we have left. So we still have a lot of platinum left, and we have a lot of phosphorus. So we have antimony, which is lesser left, and then we have indium here, which is we don't have much left. So that means down here we will know that say we don't have an unlimited supply of metals. So metal ores are finite resources. So in order to make sure that we have enough or sufficient metals to use in the future, we will probably need to recycle. We have to recycle because these metals, they are not renewable. So if you're interested, this is the amount of consumption that the proportion of the consumption of metals, right, that are met with recycled materials. So most of the lead is recycled. Then we can nickel, that is about a third. Copper is about a third. So we are still mining for more metals. I mean, not all our demands are met by recycling. What question 5 have down here is like this. It says, as the demand for the metal increases, the need for recycling will increase. So which row shows the different type of resource that metals are, and then what is the advantage of recycling them? So back to this slide, you will see that it's written down that metal ores are finite resources. That means metals itself are finite resources as well. So we can strike out C and D, which tells us about metals are infinite resources. So then we explore A and B. So A and B, we can scrutinize them and see each of the options whether it's an advantage or not. So for A, it says that a large amount of waste material is produced during recycling. Is this an advantage? Large amount of waste material doesn't seem to be talking about advantage. So we look at B. B says that recycling will save energy and cost compared to extracting new metal. So this is correct. This is an advantage. So answer should be B. This section is about extraction of iron. So this is a blast furnace. Okay, so in this blast furnace, you will see that the raw materials are hematite, coke, and limestone. This is the raw material. So oxygen or hot air comes in from below, and then ultimately you get molten slag and iron. So how extraction of iron is done is you will heat the iron ore with carbon inside the blast furnace. So then high temperatures in the blast furnace, and then chemical reaction will take place, and ultimately you will get the molten iron and the slag. So stage 1, so you have carbon going in and react with oxygen. So a very exothermic reaction, that means heat is released. Then the reaction happens, and then this section here will be about 1900 degrees. So carbon plus oxygen will give you carbon dioxide. Carbon dioxide is produced here. Then stage 2, so this carbon dioxide will react with more carbon, which is this inside the blast furnace, and then you will get carbon monoxide here. So remember, just now we have the hematite, which is the iron 3 oxide, and the iron 3 oxide will react with the carbon monoxide that is being produced, and you will get iron and carbon dioxide. So this is what we want. So the iron, liquid iron, will then sink down to the bottom. So you'll get molten iron right at the end, the bottom. So then you can drain off the molten iron. So the gases that is produced, right, will ultimately eventually become a waste gas. Then in the hematite, we have impurities plus iron 3 oxide. So these impurities, right, are actually sand, silicon dioxide. So what happens is, right, we need to remove the sand that is contaminating the liquid ice. So just now we have limestone. Limestone is calcium carbonate. It will decompose under high heat to produce this carbon dioxide and calcium oxide, and calcium oxide is a basic oxide. So the basic oxide here will react with silicon dioxide, which is the acidic oxide. Then you get calcium silicate, which is, so this slag can be used for building roads and making cement, So question 6, we have a blast furnace. So the question asks, why is limestone added to the blast furnace? Okay, from the last slide, you'll know that the purpose of the limestone is to get rid of impurities such as slag. So it's quite obvious. So this question is actually more of a textbook question. You can find the answer from the textbook. So answer is C. So question 7 is another question that you can easily get the answer from the text or from your notes if you or it's something that doesn't require too much thinking. You can get the answer pretty easily. So in this, it talks about the extraction of iron from hematite in the blast furnace. So you can go back to the earlier part, say the stage 3 of the reaction of iron oxide, which is hematite, with carbon monoxide. So iron trioxide reacts with carbon monoxide, you'll get iron and carbon dioxide gas. So then we come back to this, you'll see hematite plus carbon monoxide gives you iron and carbon dioxide. Answer B. Okay, question 8. This is another textbook question. So So we have a blast furnace again, and then now they say what leaves the furnace at here. So back to our setup. Here, can look at right at the bottom here. So the molten iron is at the bottom and on top is slag. So then we know this is molten iron, then on top is slag. So answer is B. In question 9, okay, the equation shows you some of the reaction that happens in the blast furnace. Then they ask what is the function of coke. Okay, so you have the reaction here. Coke is carbon. So carbon down here reacts with oxygen to produce carbon dioxide. So then the second part here, coke reacts with carbon dioxide to produce carbon monoxide. And ultimately this carbon monoxide comes over here. Okay, so then the carbon monoxide will react with the iron oxide, so you get iron in the end. So what is the function of this coke? Does it make slag? Okay, look at B. Does it make slag? No, right? So out. So then part C, oxidize means reacting with oxygen. So carbon monoxide there is actually reducing hematite, not oxidizing. So C is out. Then coke does not react with limestone directly. Limestone decomposes. So answer is A. It makes carbon monoxide in the end here, and that is used to reduce the iron ore. Question 10, you say, which statement about the extraction of iron in the blast furnace is correct? So we have to go back to the whole extraction of iron from the blast furnace process. So you can refer to it in your books, your notes, whatever. Statement A, coke reacts with limestone to produce slag. It is not correct. Limestone becomes calcium oxide, and calcium oxide reacts with impurities to produce slag. So statement B is produced when hematite reacts with carbon monoxide. So it's like this plus carbon monoxide gives you iron and carbon dioxide. I didn't balance. I think this is correct. Then C, limestone reacts with hematite to form iron. So explaining B will explain C. What reacts with hematite is carbon monoxide. So this is gone. Then D, oxygen is mixed with hematite before it enters the blast furnace. Oxygen is introduced together. They are introduced together with hematite together into the blast furnace. So answer is B. So in question 11, we have this information. In the blast furnace, molten iron is extracted using the reaction of carbon monoxide with iron 3 oxide from hematite. So we are supposed to identify the correct equation. So first thing first, you want the correct equation, we must have the correct product. So you know it's iron 2 oxide plus carbon monoxide gives us iron and carbon dioxide. So the one A here has oxygen and D has oxygen, that means these two answer is wrong. Then we go to B and C, which has the same, the correct reactants and correct product. So the only difference between B and C is the state of the metal. So look at this. At the end of the reaction, we will get molten iron. But in C, right, in C, you get solid iron at the end. So C is wrong. So answer B. Okay, we have come to the last part. So the process of rusting. We have to investigate the conditions for rusting. So there are a few cases here. So when the first case, there's no oxygen and water is present, then iron does not rust. Then second case, you have no water and air is present. Okay, rusting doesn't happen either. Then the third one, you have water and air present and rusting takes place. So the criteria for rusting will be you having to have air and water at the same time. And case number 4, it's an acidic solution. So more rusting takes place. So at the end, the conclusion is you need air and water to rust, and salt makes rusting faster. Okay, so this is the condition that we have. So in this case, iron is exposed to air, hydrogen, nitrogen, and oxygen. Okay, so we have to first note this. Air is about 20% oxygen and 80% nitrogen, 79. So that means, right, at the last test tube, oxygen will be fully used up, totally used up. Then in the first column, this one, 20% will be used up. And because iron does not react with hydrogen or nitrogen, so these two, no change. So then they say in each tube does water level rise the most. That means will be the oxygen, because it's completely used up. All the water will fill up the entire space in the test tube. Answer D.